Okay, so holes occur when you have a function and there's some value of x that gives you 0 over 0. So there's an x value that makes the numerator and denominator equal 0. Okay, and that x value is actually the x value of the whole. And then to find the y value of the whole, you take the x value, plug it into the function, the reduced function, and that gives you the y value. Okay, x-intercepts are when y equals 0. But rational functions, if you don't remember, I think everybody did rational functions before AMI last year. I think it's like the last thing you guys did in Algebra 2. Rational functions basically means fractions. So if y is supposed to equal 0, you need to think about, well, like fraction equals 0 when the numerator equals 0. So x values that make only, make sure you put the word only in there, the numerator equals 0. Because if it also made the denominator equal 0, it would be a whole instead of an x-intercept. There can only be one of these at a time. Only one at a time. Okay, so if it only makes the numerator 0, it makes the fraction 0, which makes y equal 0, and then that's an x-intercept. If it made the numerator and denominator 0, we end up having a hole in our graph. And then almost the same idea. Vertical asymptotes are when you try to divide by 0. Okay, so x values that make only, underline only, the denominator 0. Again, there's a lot more to graphing rational functions, but on this handout, we're just going to focus on these three because you can see how similar they are. If there's an x value that makes only the denominator 0, it's a vertical asymptote. There's an x value that makes only the numerator equal 0, it's an x-intercept. And if there's an x value that makes them both 0, not just one of them, but both, that's how we get a whole instead. So we will use this on Wednesday as well. But it's kind of nice to do these separately since they're so similar. It kind of helps you focus on this part of the skill. Okay, so looking at question 4, how to know where the holes, x-intercepts, or vertical asymptotes are. Well, we want to know what numbers make the numerator 0, the denominator 0, and what numbers make both of them 0. So no coincidence, we talked about solving quadratics because that's essentially what we're trying to do here. And I guess if you just couldn't figure out one of these, hopefully you have the product sum method or a backup plan. Or I guess worst case, you could do quadratic formula. But you don't want to have to do quadratic formula just for the numerator and quadratic formula just for the denominator. Ideally, you want to be able to factor the numerator so that we can see -1 and 4 makes the numerator 0. Factor the denominator so that you can see 4 and -2 make the denominator 0. And now we just need to think about this stuff. there's any numbers that make both the numerator and denominator 0, that will be the x value of the whole. We'll come back and do the y value later. If there's any number that makes just the numerator 0, that would be a x-intercept. And if there's any numbers that make just the denominator 0, those will be vertical asymptotes. Now, vertical asymptotes are vertical lines, so you need an x equals here. You might include that in your notes there. X-intercepts are a point, so make sure you write that as a point. Eli, you need to take your headphone out. Thank you. Okay, so the y value of the whole, I had you write in the notes here. The x value is the number that makes the numerator and denominator 0. So 4 and 4 for this question. The y value comes from plugging in the x value into the reduced function. And so what I mean by that is, now that we have this factored, imagine these factors canceling out. X minus 4 cancels out with an x minus 4. Plug this in to the reduced form, what's left behind, and you would get 5 over 6. So make sure you illustrate that some way that you look back at that and you can see where that number came from. Plug in the x value into the reduced function. Okay, questions about number 4? Is this familiar? You remember doing any of this last year? No? Yeah.
Could it also be like, for like the vertical asymptote, could it also be 4, x equals 4 as well?
Nope, because vertical asymptotes are x values that make only the denominator 0. 4 didn't just make the denominator 0, it also made the numerator 0. Right, if it makes both of them 0, like 4, it's a whole instead of one of these two. And that's why this word only is super important. Graphically, only one of these can happen at a time. Okay, so I'm going to go ahead and graph this one. I don't know that you need to graph many of these, but it makes sense for us to look at what we're talking about, and we can kind of verify our answers here. Good idea to put parentheses around our numerator, put parentheses around our denominator. Graph. So this is a graph we're talking about. So this is what a vertical asymptote looks like. It's a vertical spike in the graph, and it looks like it's at x equals -2. Confirms this. Looks like the only place it should touch the x-axis is x equals -1 and nowhere else. That looks to be true. And then the whole is very hard to see because it's when x equals 4. So right here, it doesn't look like it skipped anything because it hits the points right before it and the points right after it. And so since your calculator only has a limited number of pixels and it has to round, it looks like it hits everything. So the only way to know if there is actually a hole at 4 is to hit trace 4 enter so that it jumps to that point. And then notice down here, it says when x is 4, y doesn't exist. So it knows there's a hole there. Now, as far as the y value, I guess you could inch a little bit to the left, inch a little bit to the right. The numbers are around 0.54, 0.53, and I said it was 5/7 or 5/6, which is about 0.83. So your calculator does a very poor job of showing you holes. It's just not programmed to make that obvious. But we don't need that because we can find it algebraically anyway. Okay, so let's look at another one, and then I will have you start to try it as well. Okay, so holes are going to be x values that make the numerator and denominator 0. X-intercepts are going to be x values that make only the numerator 0. And vertical asymptotes are numbers that make only the denominator 0. So anyway you cut it, I got to figure out what numbers make the numerator 0, what numbers make the denominator 0. Well, the denominator is just a GCF. So where x equals 0 and where x plus 5 equals 0. The numerator has a GCF of x and factors as an x plus 2 times an x plus 1. So where x equals 0, where x plus 2 equals 0, and where x equals x plus 1, where x plus 1 equals 0. Okay, so maybe you don't factor it quite as quickly as me, but you see the process. If there's any numbers that make the numerator and denominator 0 at the same time, that's the x value of a whole. If there's any numbers that make just the denominator 0, those are vertical asymptotes. So that's going to be a vertical spike in the graph. And if there's any numbers that make just the numerator 0, then those show up as x-intercepts. And then to find the y value of the whole, you need to plug this in to the reduced form here. So imagine these factors canceling out, reducing, and plug it into what's left over. You get 2 times 1 over 5. So 2 fifths. So of course, when we get to this last test, we're either not going to let you have a calculator or we're going to make you explain your work. But I could graph this guy. And it certainly helps while you're practicing here to see what we're trying to find. Because again, before your next test, we're going to ask you to graph these things. So I said it should only touch the x-axis at -2 and -1. So that's kind of hard to see, but trace -2, enter, confirms. Trace -1, enter, confirms. My x-intercepts look good. We said there was a vertical asymptote at x equals -5. So here's where that is. And notice how there's a spike in the graph. Usually there's another piece here, but it doesn't have to be. So there's a vertical spike. X can never equal -5, so it can't exist there. If you hit trace -5, enter, it's going to say when x is -5, y doesn't exist. And the hardest one to see is the hole, but I think there's a hole when x is 0. So trace 0, enter, and sure enough, even though it looks like it hits at that point, when x is 0, y doesn't exist, so there is a hole there. Now your calculator gives you no help with finding the y value, other than you can cursor over and see that it's about 0.3, cursor over, it's about 0.5. So somewhere between 0.3 and 0.5. I said it was 2 fifths, which is certainly between 0.3 and 0.5. Yeah.
So like if you zoomed in on a calculator, you'd see like the graph really stops, like there's no line there. That's why it's a hole, right?
I bet you would have to zoom in quite a bit, and I don't know that it would ever show you. Okay, I went too far, but the problem is, I mean, it's literally just one instance where it doesn't exist. Everything to the left and everything to the right. So when it's like filling in those pixels, it's trying to see, does it exist here? Does it exist here? So it's like showing you it makes it look like it exists in the middle. There's no good way for it to like bubble in a circle like we will do. So yeah, your calculator just doesn't show holes very well, but that's okay because we can find them algebraically this way. Okay, so number 6, I'm going to factor for you. And then I want you to put some thought into what you think these 3 answers should be. All right, well, the denominator's factored. There's a lot of factoring involved, but not everything has to be factored. The numerator, nine and 7 would be 63 minus 18 minus 7 would be minus 25. Okay, so there's the numerator factored for you. So write out what numbers you think make the numerator 0. Write out what numbers you think the denominator equals 0. And then see if that tells you the holes, the x-intercept, and vertical asymptote. Okay, so it looks like 2 makes the denominator 0, 9 makes the numerator 0, and also 7/2. So is there any number that makes the numerator and denominator 0? Okay, not everything has a hole. Most functions don't have a hole. A lot of times with rational functions they do, but not always. Numbers that make you only divide by 0 are vertical asymptotes. So there should be a vertical spike at x equals 2. I went ahead and graphed this for the C. Here's where x equals 2. It looks like it's more like x equals 3, but that's just because I'm kind of zoomed in. If I zoomed out more, well, now you can't really see x equals 2, but there's a vertical spike at x equals 2. So that's what that is trying to find and describe. And then x-intercepts are numbers that make only the numerator 0. So that was both of those values. And so it better touch the x-axis at these 2 places and nowhere else. So trace 9 enter confirms that 9, 0 is a point. Trace 7/2 confirms that 7/2, 0 is a point. So I can see both of these on the graph fairly easily. Holes, not so much, especially when it's not there. It's not going to be able to show that to you. Okay, so you try 7 and you do the factoring piece too. I'll give a little more time since you got to factor that numerator. And feel free to work ahead if you feel like you're doing it correctly. Okay, looks like the numerator factors as a 3x plus 1 times a 2x minus 3. So again, you don't have to be able to factor quickly, but you have to be able to factor. So if that's still a weakness of yours, it's going to hurt a little bit more this unit. You need to get in some extra practice. The denominator equals 0 at 0, x equals 0 at x equals 0. This equals 0 at negative 1/3, and this equals 0 at positive 3/2. So there's no number that makes the numerator and denominator 0, which is how you get a hole in your graph. There's two numbers that make our numerator 0, so that's how you get x-intercepts. So I'm not going to graph this one, but if I did, that's for the two places that would touch the x-axis and nowhere else. And numbers that make only the denominator 0 show up as vertical spikes or vertical lines called vertical asymptotes. So it's very similar, like I'm almost saying the same thing for all three of these. So that's why you need to make sure you understand the difference between those. Any question from number 7? Okay, go ahead and try one more with number 8. And then I give you a chance to maybe jot down any notes you feel like you need to add to this. And then we'll jump over to the other handout and you guys can come back and practice 9 and 10 at the end of class. Okay, so let's go ahead and check this one. Now again, this unit is on rationals, but we're only focused on graphing. So by the end of this week, you should have a very good idea of how to come up with this whole graph. Today, we're just talking about how to find these vertical spikes anywhere where it might cross the x-axis and anywhere where there might be a hole in the graph, which is a good portion of the graphing. But there's other stuff like y-intercepts and slant asymptotes and horizontal asymptotes. There's more to it. But for the three that you're focused on today, you have to know what numbers make the numerator 0, what numbers make the denominator 0. So you got to be able to factor things like difference of two squares and GCF. Any number that makes just the denominator 0 is a vertical asymptote. Any number that uniquely makes the numerator 0 is an x-intercept. So if I switch back to my graph, there should be a vertical spike at x equals 0. That looks good. I said that there's an x-intercept at -5, and that's not true. I have a mistake in my work, don't I? Yeah, this guy equals 0 at -5. So I just did that too quickly. So it's actually, yeah, 5, 0. So 5, 0 makes a lot more sense. -5, 0 didn't. So my mistake there in red. And then any number that makes both the numerator and denominator 0, it can't do these two things because your graph can only do one of these things at a time. But that would be the x value of your hole, and then the y value, which I'm going to recommend that you write this out in words that make sense to you, because this is the part that's the hardest to stick for people. You need to plug this back into the function, but not here. If you plug it in here, you get 0 over 0. That doesn't help you. You need to plug it into the reduced, let these reduce out, and plug it into what's left over. -10 over -5 would be 2. So it skips the point at -5, 2. Now, usually if you graph it, if you hit trace -5, enter, it tells you when x equals -5, y doesn't exist. And this time our calculator did do a little bit better. Can you see how there's a tiny little gap there? So it was trying to show me a hole this time. It's just that it's not reliable, it's not dependable. And also if you just glance at this graph, you may not even notice that tiny little thing right there. But it is trying to show you that it doesn't exist there. Okay, so is there any specific questions y'all feel like you need to ask about how to find those three things? Okay, then I'm going to take just a minute. If you feel like you need to have more detailed notes here, if you'd like to erase what I had you write down and maybe rewrite it in a way that makes more sense to you, then please do before we put that one aside. I do want you to finish the other two questions today, but I'd kind of like you to come back to do it, make you think about this topic again today. So go ahead.